Solar Weather Report October 2021 from October the 14th. One of the most violent phenomena in our Sun is a coronal mass ejection, or CME. This is when material from the Sun is expelled into the solar system following an explosive event in the outer layers of the Sun. A week and a half ago, we experienced precisely this. On October the 8th, a solar flare was observed in the Sun from region of sunspot number 2882. By October 11th, the Earth had been hit by a south-pointing B sub Z stream of magnetically charged particles which couple to our geomagnetic field. This energetic stream of particles then traveled to the night side of our planet and recoiled into a second particle flow that was funneled into the northern and southern polar regions of the Earth. That's where our planet's magnetic field is the weakest. All of this resulted in a dramatic display of the Aurora Borealis, which could be seen all over Canada and the northern US. A similar display was also caused by the Aurora Australis over Antarctica and southern South America. Are we still seeing the effects of the CME? Can we still see auroras from northern latitudes? The answer is no and no. It turns out that the CME effect was intense but short-lived, and we no longer see any effects due to it in the Earth's geomagnetic field. As usual, a look at our numbers tells us the complete story. The solar flux index, or SFI, is currently at a respectable value of 84, while the smooth sunspot number, or SSN, is at 27. Sunspot number 2882 is still visible from Earth, and a weaker sunspot, number 2885, is located relatively close to it on the solar disk. On the Earth side, the geomagnetic indices show a planetary K sub P index of 1 and an average A index of 6. However, we experienced quite different numbers during the CME impact. The first indication that something was taking place at the Sun was a large photon flux coming from the Sun on October 8th and causing our solar flux index, which measures 10.7 centimeter EUV radiation from the Sun, to spike to 92. On October 12th, 3 days following the observation of the solar flare, the coronal mass ejection hit Earth and caused our average A index to climb up to a value of 45, and our K sub P index ramped up to a value of 6. We see in the following A index values the effect of the CME and our geomagnetic field from various observatories, namely Fredericksburg in Virginia, College in the Fairbanks area of Alaska, and Boulder in Colorado. But how does this affect our ham radio propagation? Well, we can look at WSPR data from WSPR Live for the period around October 7th through the 9th, when the CME was just getting started at the Sun. The WSPR Live website contains interesting data such as the ratio distance per power in kilometers per watt of WSPR signals recorded. So if this ratio curve is large, then our ham radio signal is propagating very efficiently. In other words, large distance using little power. Looking at this WSPR Live data, we notice something interesting on the 7 MHz band. Notice the yellow boxes showing an anomaly. Could this effect be noise, or can it be seen on another band? Well, let's look at a similar data on the 10 MHz band. Yep, there it is. The anomaly shows. Okay, but what about the 3 MHz band? Glad you asked. Here it is. So the data seems to show a correlation between the ratio curve of efficient WSPR signal propagation and the time that the CME was being generated by the Sun. Maybe. We remain skeptical, like good amateur radio enthusiasts, but interested. Again, the interesting correlation and kilometer per watt anomaly started before the SFI spike. Right, so this is all part of experimentation, and data mining is now possible thanks to the work of ham radio operators around the world, thanks that add to the WSPR database. Now, let's get on the air in whichever mode we prefer and make contacts. Good luck good contacts, and 73.